Who doesn't like a good explosion in a movie? There have actually been a few times where I've put on a Michael Bay or a Quentin Tarantino movie just for that very reason. However, most movies get explosions wrong. Sometimes very, very wrong. So today, let's have a look at how they get them wrong. When it comes to making big explosions, there's two things that you have to look out for. The first one is enthalpy, or simply energy, and the second one is entropy. And no, I'm not repeating myself, it is something different. But we'll come to those a bit later. But for now, let's just look at some explosions. One of my biggest problems with explosions in movies is fire. Yes, fire. We're all familiar with the Hollywood big fireball explosions. But this isn't very accurate, and in fact, unless you're using incendiaries or petroleum, explosions generally don't look like this. Take this scene from Transformers, or, well, any Michael Bay movie, and you get almost a perfect example of what an explosion should not look like. In fact, one definition of an explosion is a rapid expansion of gas. Wait, what? Anyway, let's back it up a bit. Going back to my earlier 2 points, the first one is energy. Well, it's an explosion, the more energy the better. Nice and easy. However, it's the second one, entropy, that we'll need to focus on for a little bit. Entropy in its simplest form is a measure of randomness or disorder in a system, and it's responsible for, amongst other things, gas filling a room, or your coffee or tea going cold. So, on top of energy being released, an explosive reaction must also create a lot of gas particles very quickly. They all want to go somewhere, and that somewhere is outwards. And it's this rapid expansion of gas, and not just the fire and energy, that makes an explosion so forceful. Most definitions I found for explosions included both a rapid temperature and pressure increase. This is why you find nitrates in a lot of explosives. They release a lot of energy and a lot of gas when they react. Think about it, you've got TNT or trinitrotoluene. You've got ANFO with its ammonium nitrate, or gunpowder with its potassium nitrate. You've also got gun cotton with its cellulose nitrate, and... sorry, what were we talking about again? If we look at this footage, one of my favourites from Mythbusters, you can clearly see the shockwave coming out of the explosion as the cement truck disappears. There is still some flame, but as you can see, after an initial flash, there isn't really anything. None of that continuous big fireball that you see in Hollywood. For example, grenades don't explode like this. What you're seeing here is an explosion deliberately made to create flame, normally using petroleum of some kind. I'm sorry, but grenades just don't go off like that. Also, pulling grenade pins out with your teeth is surprisingly difficult, so don't try this, just use your finger. The movie Stalingrad does at least not have giant nuke-powered flame grenades, but the explosion doesn't seem to emanate all that evenly out from the grenade. It kinda looks like someone's just turned on a giant leaf blower. A small side note, since we're talking about fire, is that where there is smoke, there is fire. Or at least in this case, where there's an explosion, there's generally going to be a lot of smoke. For some reason, movies seem to ignore this fact. Explosions generate a lot of smoke. Particularly if you've got something older, like a musket or a cannon or any older explosives like gunpowder, visibility should be rapidly reduced. Whilst some movies get this correct, it seems to be overlooked for some reason. One movie that does get it pretty good is A Bridge Too Far. Starring Sean Connery, this movie focuses on Operation Market Garden from World War II. In one scene, a tank column comes up against a German position. The British employ artillery, and I'm wondering if they used actual artillery here, because it's pretty realistic. For the movie, they actually acquired real World War II vehicles and equipment, so that might have been a possibility. This scene also features a bombing run as well, and the amount of smoke, the amount of fire, and the kind of results you get from it are pretty damn good. Overall, I think this movie is one of the better ones. It just seems to be something about older movies having to do it for real. Also, another side note, petrol tanks don't make for good bombs. Bullets won't make them explode, and in fact, they're a terrible way of setting anything on fire. Unless you're using specific ammunition like tracer rounds, you haven't really got much of a hope. Also, even if you did set it on fire, petrol tanks burn, they don't explode. So, I'm sorry, but this just isn't going to happen. When it comes to explosives, size counts. There's a nasty reason why nuclear bombs were invented in the first place. But even they probably aren't as big as you're expecting. Early tests with nuclear bombs failed to sink even more than a handful of ships that were directly targeted. However, it was found out that the radiation got almost everywhere and was impossible to get rid of. So unless you're close to the center of the blast, that's going to be your biggest worry. Junior, what are you doing? Seriously, get away from there. It's a nuclear bomb, what are you doing? Get away from there, don't go closer to it. Forget it. If we look at Independence Day, we get a very good example of what not to do. Even Indiana Jones had a more realistic scene than this. For a start, it just seems to be one giant fireball. Explosions don't work like this. And what's perpetuating the fireball? The building's made of petrol or something? Also, why are only some cars getting picked up and thrown about and not others? Also, you can't really hide from explosions by jumping around corners like this because the pressure wave doesn't seem to care for corners. The fire might, but yeah, you're not surviving this if it is real, but I don't even know what this is meant to be at this point. Sticking with the topic of size, movies seem to exaggerate the power of a small amount of conventional explosives. For comparison, let's look at the infamous Vengeance weapons. The V1 and V2 had similar payloads, though the V2 was more deadly because it was harder to stop and had a longer range. These things, though, were enormous. They were designed to do serious damage, and if you look at them go off, they could level multiple buildings. But movies seem to show a similar level of destruction with a few sticks of dynamite. I'm sorry, but even if you're using high explosives like C4, you're not going to get anywhere near this level of destruction. You would need a substantive volume that seems to, for one reason or another, be ignored. I mean, if you want to bang this big, you're probably going to need a truckload of explosives. Okay, so we know that we don't want too much fire, we need some smoke, and that we also require an adequate volume of explosives. But what about the blast effect on people? Well, again, let's go back to entropy. Remember, it's the expansion of gas that is most dangerous. That is either directly by being hit by the blast wave from an explosion, which at close range could rupture your eardrums, collapse a lung, and do some serious internal bruising. 35 kPa of overpressure is generally lethal, and hiding around corners won't save you. For comparison, that's within 5 meters of a grenade blast.
Oh my God, how do they walk away in movies without flinching when it explodes behind them? There's no way!
The other big danger is the explosion pushing shrapnel out. I mean, you see people walking away from explosions all the time, but in real life, They'd be lucky if they didn't get a few nasty lacerations or completely torn to shreds. In fact, if you're this close to an explosive about to go off, don't saunter away at full height. Try and get out of the way. We also need to consider momentum. Movies seem to love showing people being thrown into the air. Like so. However, unless the bomb went off directly under you, this isn't going to happen. And even if it did, you're not likely to be thrown that far. If you're not on top of the blast, then by the time the pressure wave hits you, there's not nearly enough momentum in the upwards direction to throw anything into the air. In fact, if you are close to the explosion, you're just going to get knocked to the ground. Now, I just want to make a quick note on underwater explosions. Shrapnel isn't particularly effective because the water slows it down, so it doesn't get very far. In fact, they rely on pressure waves. The initial explosion creates an air bubble and an initial shock wave. This then collapses as the weight of the surrounding water comes rushing back in to fill that air as the bubbles move towards the surface. This can create another shock wave. This process can also repeat multiple times. Now, let's look at one of my favorite Disney cartoons of all time, Atlantis, the Lost Empire. Spoiler alert, they get attacked by the Leviathan, a giant mechanical lobster with a very cool mouth cannon. And they try countering it with torpedoes. Lots of torpedoes. Albeit unsuccessfully. However, the blasts from the torpedoes are actually pretty well depicted. You see initial flashes, there's not too much debris, although in one or two scenes that might be questionable, though overall they're pretty good, and there is also a lot of bubbles, represented here by the blue. Now, whilst you don't really see these pockets collapsing and then the bubbles rushing to the surface, overall, for a cartoon, I'm very, very impressed. This is a fairly realistic scene for such a great movie. Now, onto one of my favourite war movies, Das Boot. After being nearly rammed by a destroyer, depth charges are used to try and sink the U-boat. And here, the depiction of the underwater explosions is really, really good. After an initial flash, you see a mass of escaping bubbles, and the U-boat gets rocked around as it's hammered by the effects of the explosions. A very long movie, but a very good one. Now on to space booms. I'm sure you've all heard the expression, in space no one can hear you scream. And sound doesn't travel in a vacuum. Space is a vacuum. So we good? Not quite. Quantum mechanics gets very unhappy if you have a perfect vacuum. So there is still stuff in space. Just not much of it. And the explosion will still create a lot of gas that has to go somewhere. In space, it'll expand very quickly. So the explosion would still be audible with a sensitive microphone. However, if you're in a spacesuit or a spaceship, unless the blast went off virtually in your face, you're not going to hear it. It'll still be there. But sorry, Star Wars, there is no way the Death Star made a bang. Whilst the blast itself wouldn't cause a lot of damage, the shrapnel and debris would be a serious problem. For one, there's nothing to slow it down, so it'd just keep travelling out. And two, spaceships and humans in spacesuits are particularly vulnerable to flying bits of metal. More so than most things like tanks and buildings on the ground. So on that note, remember, I'm almost a doctor, and until next time, be like a proton. Stay positive. Yeah.